On this one, we want to graph the function using the techniques of shifting, compressing, stretching, and/or reflecting. We're going to start with the graph of the basic function shown below. We've got g of x equals 6 square root x. So we don't have the basic function shown, we're going to reproduce it. And our basic function is the square root graph. So we're talking about y equals the square root x. That's our basic function. We can only take the square root of 0 and positive values because the square root of negative numbers will give us imaginary and we won't be able to put them on our graph. So we're going to use, starting with 0, positive numbers only. So we've got 0 and then a positive 1. I'll choose a positive 4, a positive 9, and 16. I've chosen these numbers strategically to be perfect squares so that when we calculate the square root, we get nice ordered pairs to plot on our graph. So this will give the square root of 0, which is 0, the square root of 1, which is 1, the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. So the ordered pairs that we're going to plot for our basic function are 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. So we'll plot those points. We have 0, 0, 1, 1, 4, 2, 9, 3, and 16 is going to be a little bit of our picture, so that's 13, 14, 15, 16, 16, 4 would be about there. So this is the graph of y equals square root x. But we want to graph the transformed function g of x equals 6 times the square root of x. So we've already determined that our base function is y equals the square root of x, and we're trying to graph g of x equals 6 square root x. So we have one transformation, and that one transformation is the multiplication by 6. When we have a multiplication by 6, that's an indication of either a stretch or a compression. So the way we determine which one it is, and there's a vertical stretch, a vertical compression, or a horizontal stretch or horizontal compression. So what we notice is that the 6 is multiplied onto the square root function, and that is outside of the square root function. So we know that this is either going to be a vertical stretch or a vertical compression. And the way that you tell the difference between a stretch or a compression here is the value of the number. This number of 6, let's call it C, is greater than 1. So because that 6 is greater than 1, that makes this a stretch. If the number was in between 0 and 1, like a half, it would be a compression. So we're going to take this starting graph right here, y equals square root of x, and we're going to stretch it vertically. And what that means literally is that every y value will get multiplied by 6. So we have this ordered pair at 0, 0 has a y value of 0, and it will still be 0. 0 times 6 is 0. Then this point has a y value of 1, and that will become 6. 6 times 1 is 6. So it becomes 1, 6. And this next point here has a y value of 2, and 2 times 6 is 12. So that point becomes 2, 12. And so you can kind of see that our graph is getting really stretched out. It's almost hard to notice that it's going to be curved. So it's stretching out like this and will become the same shape but stretched out vertically. So I noticed that I made a small mistake with where I placed my points, at least my second point here. So this point that I used is 212 instead of 412. So let me make that correction so that we can see this picture a little bit better. So it should be 1-6 and 412, and now it looks a little bit more curvy. I didn't do the other values because they're going a little bit too far off my picture. So this is where we see that square root graph going. Thank you for checking out my videos. Have a great day.